In this video presentation, we are going to see the capacitance of two dielectric medium. We have all known that capacitance is a storage device which stores energy in electrostatic field. Another example of energy storage device is inductance, which stores energy in magnetic field. So this is the basic difference between capacitance and inductance. In this presentation, we have to derive the expression for the capacitance of two dielectric medium. We have known that the capacitance it can be formed by separating two conducting plates. That is, two conductors or two conducting plates which can be separated by a distance. That is called your capacitance or capacitor, or it is also called as condenser. And in this case, we have to derive the expression for capacitance. So the basic expression of the capacitance is C is equal to epsilon A by D, where epsilon is permittivity of the dielectric medium. Because the permittivity of the dielectric medium is very important parameter when we are going to derive the capacitance of that particular case. So the permittivity, generally it is known as epsilon, whose formula is epsilon naught and epsilon r, where epsilon naught is absolute permittivity, where epsilon r is relative permittivity. The relative permittivity is depending upon the particular material which we have chosen for dielectric medium. Dielectric medium is nothing but the insulating medium which is present in between the conducting plates. That is, because of this only the capacitor is having the capability to store the energy in electrostatic field. So each and every dielectric material or insulating material is having its own permittivity, relative permittivity. The relative permittivity is denoted by epsilon r. So the capacitance of any material is depending upon the three important parameters. One is relative permittivity, another one is area of the conducting plates, and the third one is the distance between the conducting plates. Now we are going to derive the capacitance of two dielectric media. Before going to explain this diagrammatic representation of this capacitance, we have to see the structure in deriving the expression for capacitance. The step 1, we are going to find out electric field intensity E1 and E2 in the medium 1 and 2. This is the first step. And second step, we are going to find out the potential across the medium 1 and medium 2, that is denoted by V1 and V2. Step 3, we are going to find out the capacitance by using the direct formula. Let us see the diagrammatic explanation of this expression. Consider a parallel plate capacitor which consists of two dielectric medium which is having different permittivity. In this case, we can take the first dielectric medium, that is medium 1, whose relative permittivity is denoted by epsilon r1, and the second dielectric medium, that is medium 2, which consists of relative permittivity denoted by epsilon r2. And the distance between the first dielectric medium and a parallel plate capacitor is d1, and the distance between the second plate and the second medium is considered as d minus d1, where d is the distance between the two parallel plates. So this is the total distance between the two conducting plates or two conductors, or simply it is called as two parallel plates. And V1 is the potential across the medium 1 and V2 is the potential across the medium 2. E1 is electric field intensity in medium 1, E2 is electric field intensity in medium 2. So here, what is our aim? Our aim is to find out the capacitance across these two parallel plates. Now we are going to see the step 1 the step 1 is to find electric field intensity in medium 1 and medium 2. Before going to derive this electric field intensity, we should know the relation between electric flux density D and E. And we all know that where D is equal to epsilon into E, from this we are going to take the expression for E is equal to D divided by epsilon, where epsilon is taken as D divided by epsilon naught and epsilon R. So epsilon R is an important parameter, where epsilon R1 is for medium 1, epsilon R2 is for medium 2. So by using this relation, we are going to derive the expression for E1 and E2. And we all know that the D also can be written as flux per area. That is, electric flux density is electric flux per area, Q by A. Now we are going to substitute this D in the above expression. So the expression for E can also be written as Q divided by A into epsilon naught and epsilon R. From this we are going to derive the expression for E1, which can be written as Q divided by A by epsilon naught epsilon R1. And similarly, the expression for E2 is given by Q divided by A into epsilon naught and epsilon R2. So where E1 is electric field intensity in medium 1 and E2 is electric field intensity in medium 2, and this is expression 1 and this is expression 2. Next we see the step 2. So what is the steps 2? The step 2 is to find the potential across the medium 1 and medium 2. So here we just assume the potential across the medium 1 and medium 2 can be taken as V, where V, it can be written as V1 plus V2, sum of the potential across the medium 1 and medium 2. So here V1 is the potential across the medium 1 and V2 is the potential across the medium 2. So here the relative permittivity for the medium 1 can be taken as epsilon R1 and relative permittivity for the medium 2 can be taken as epsilon R2. So from the step 1 we are going to write the expression for the potential drop, that is V. Simply it is considered as V. So now we know the relation between V and E, that is potential and your electric field intensity, where V it is given as E dot D, where E is electric field intensity and D is the distance. So by using this general formula, now we are going to write the expression for V1 and V2. So here the V1 it is for the medium 1 and this V1 can be written as E1 into D1, where D1 is the distance between the plate and the medium 1. Similarly, the V2 can be written as E2 and the corresponding distance between the medium 2 and the plate, it is taken as D minus D1. So this is expression number 3 and this is equation number 4. So from this we write down the expression for total potential, that is sum of V1 and V2. Now the V1, V2 can be replaced by its expression, that is E1 into D1 plus E2 into D minus D1. And now the equation for potential drop can be written as V is equal to E1 D1 plus E2 into D minus D1. Now we are substituting the equations for E1 and E2 which have been derived in the step 1, where E1 is Q divided by A into epsilon naught epsilon R1 into D1, and E2 can be written as Q divided by A into epsilon naught epsilon R2 into D minus D1. So this is equation number 5. Next, we say the final step, that is step number 3. Here our aim is to find out the expression for capacitance. So capacitance, it is denoted by the letter C, where C is the capacitance. So for finding the capacitor, we should know the relation between the capacitance and the potential. So we have all known that where C is equal to Q by V, where Q is the charge, V is the potential. This equation can be derived from the basic expression Q is equal to CV. So this is the basic expression for capacitance, where C is equal to Q by V. Now we are going to write down the another expression for capacitance. So C can also be taken as C is equal to A epsilon by D, and it is also written as A, where epsilon can be written as epsilon naught and epsilon R by D, where epsilon R, here epsilon R is an important parameter, and it can be taken for medium 1 as epsilon R1, for medium 2 as epsilon R2. Okay, and now we are going to write down the expression for V, where V, it has been derived in the step number 2. So from this, now the capacitance equation can be written as Q by V. Now we are going to substitute the expression for V in this expression. So here we can substitute the equation number 5 in this expression. So Q divided by write down the expression for V. Before writing the expression for V, V can be reduced to the single term from the expression number 5. Here we are taking the common terms outside. So Q, A, epsilon are the common terms. So Q divided by A epsilon naught. These terms are taken outside. The remaining terms will be put into the bracket. So the balance terms are D1 by epsilon R1 plus D minus D1 by epsilon R2. So now we can have the reduced form of the expression for V. Now we are going to substitute this equation number 7 in equation number 6. So the capacitance equation can be written as Q divided by Q by A epsilon naught into D1 by epsilon R1 plus D minus D1 by epsilon R2. So now this expression can be reduced to a simple term. For this, step 3 will be continuing. Now the capacitance, so here we can take the simple term C is equal to Q by V, where V can be replaced by its expression here. So Q is getting cancelled. The remaining terms we can write it down here, where C is equal to A epsilon naught divided by d1 by epsilon r1 plus d minus d1 divided by epsilon r2, and this is the simplest form of expression for the capacitance. This also can be reduced. C is equal to A epsilon naught. Here you can take the LCM for this expression, epsilon r1 into epsilon r2. This can be taken in the numerator. So epsilon r1 into epsilon r2. The denominator will be written like this. This is the easiest form of capacitance, where d1 into epsilon r2 plus d minus d1 into epsilon r1. This is another simplest form of the expression for capacitance. So this is the final expression for the capacitor, where it is consisting of two dielectric medium having the relative permittivity epsilon r1 and epsilon r2. So from this we just take down the expression which gives the relation between the capacitance, area of the plates, and epsilon naught is the absolute permittivity, and relative permittivities of medium 1 and 2, that is the epsilon r1 and epsilon r2, and distance between the plates and the medium 1 and medium 2 can be taken as d1 and d minus d1. In this presentation, we have derived the capacitance of two dielectric medium. So normally we have known the basic concept of capacitance. Capacitance, it can be formed by two conducting plates which can be separated by a distance in between the dielectric medium or insulating medium is present. So here the capacitance is mainly depending upon the parameter epsilon r, which is nothing but the relative permittivity of dielectric medium. So in this case we have two different dielectric medium which is present in between the conducting plates. So it has been fixed by a particular distance. For that case we derive the capacitance. So in that case the capacitance, it is depending upon the three important parameters. The first one is relative permittivity of the medium 1 and relative permittivity of the medium 2, and the area of the plates, conducting plates, and third one is the distance between the conductor and the medium 1 and distance between the medium 2 and the conducting plates. So these parameters are very important to derive the capacitance of two dielectric medium concept. And in that case the first step is to find out the electric field intensity in the medium 1 and medium 2. And the second step, from the electric field intensity we found potential in the medium 1 and medium 2. So step 3 is the final step, where we have found out we have derived the capacitance by using the direct formula C is equal to Q by V. Thank you.